Okay. Fantastic. So I'd like to welcome everyone to today's webinar. The subject of the webinar is how much insulation do you need to fit a heat pump? And we'll explore that in greater detail as we go on. Just a few things to welcome people. Okay, so do say hello in the chat. Introduce yourself, where you're from, what your interest is today. Today we've got Sandy from from People Powered Retrofit is our training manager. It's going to be monitoring the chat. So the webinar will be technical, yeah, and some prior knowledge of retrofit and heat pumps will be required. So it's for practitioners, installers, engineers, architects, policymakers, community energy groups, and householders with a high level of technical knowledge. But if you're here and you're just interested, what is a heat pump? Where do I start? You know, what goes on? What is a heat pump? This is probably not the webinar for you. We do have a whole host of webinars on the Carbon Co-op YouTube page. I'd really invite you to have a look and explore there. And there's other things online that you can explore. The session is being recorded and will be made available after the event, along with the slides as well. And I'll correct the title slide with the correct date. And yeah, if you've got questions as we go along, please put them in the Q&A. As I said, Sandy from PPR will be monitoring that and having a look. Just a quick introduction to Carbon Co-op and People Powered Retrofit. So we're jointly running this session today. Carbon Co-op are a community energy organisation based in Greater Manchester. We help people and communities to make big savings in their carbon emissions. We work across sectors. We get a lot involved in energy system work, in advocacy for citizens and local authorities, and in retrofit, and especially in retrofit in a fuel poverty or area-based context. People Powered Retrofit, I am co-founder of Carbon Co-op, and I'm now business lead at People Powered Retrofit. People Powered Retrofit really is a one-stop shop for retrofit, involved in a householder service, end-to-end service for householders, but also training, hence Sandy, training manager, and we get involved increasingly in replication and ICT tools as well. So yeah, I sit across both organizations, but we both organizations are jointly running today's session. And just a little bit of background very quickly to the webinar is that Carbon Co-op and People Powered Retrofit are involved in a number of projects unified under the term Heat Pump Challenge, where we're exploring the challenge of heat pumps and looking at some of the barriers to the rollout, some of the barriers to entry into the industry for people and skills, looking also at services and service design and how we might design services better. There's funding that's come from the MCS Charitable Foundation, also Electricity Northwest. We're also working with Nesta on that project, particularly around like boiler temperatures, and quantum technology and strategy are also involved in that as well, thanks to all those people. Okay, so today we're going to be exploring a number of different questions around the heat pumps and insulation. I'm not going to go through all these, but these are basically some of the questions that we've had from people in the run-up, like how should we think about fabric as it relates to heat pumps? Is it the case that we can just put a heat pump in any kind of home, or does it need to be a passive house home before we even think about putting a heat pump in there? Are there any rules of thumb that we can think about to understand these kind of principles underlie there? Are EPCs a good guide to kind of whether a property is a heat pump ready? What are the challenges around things like hot water and other things? And from a policymaker perspective, we're thinking about what kind of incentive standards and regulatory tools that policymakers might call on to deliver effective heat pump programs and fabric upgrades together, and what kind of approaches might policymakers need to understand the actual impact of things once they go in. And my colleague Matt is going to be talking about that later. Okay, so we've got a couple of people, well, 3 people speaking. We've got Marianne Heaslip, who's from Urbed and also People Powered Retrofit. We've got Leah Robson, who's from My Energy My Way, and we've got Matt Fawcett, who's from the Carbon Co-op, and each will give a slightly different perspective. Marianne and Matt have slides, and Leia's going to respond to some of the stuff that's been said. So firstly, we'll have Marianne, then we'll get Leia on, then we'll hear from Matt. So yeah, Marianne, are you happy to take things away?
Yeah, can do. Should we keep using these slides? And then
yeah, if
you just flick them on.
Yeah, just let me know. Yeah.
So yeah, hello everyone. I'm Marianne. I am an associate principal at Urbed and also the technical lead at People Powered Retrofit. I'm an architect by training, but I've specialised in retrofit and the kind of slightly more technical end of things over the last decade or so. So I'm not an engineer. I don't design and install heat pumps, but I do a lot of work around retrofit and do the design coordination side of things, kind of fitting heat pumps in as part of bigger projects or part of a whole house project. So this question of how much insulation do you need to fit a heat pump, it's something that we get asked quite often. And I'm afraid I do that slightly annoying thing of saying, well, what is it that you actually want to do? Just answering a question with a series of other questions. Because technically, if you wanted to, you could fit a heat pump in pretty much any kind of property. Older properties, not so well insulated properties, big, small, whatever. The difference is the impact that that'll have and the results that it will achieve. So I think my answer to the question, I guess, is to ask those other questions and say, in order to answer this question for yourself or for your project, you really need to understand what your aims and priorities are and what it is you want to achieve. Flick it on, Jonathan. I think the big one that a lot of us are very concerned about is obviously the need to reduce carbon dioxide emissions, and to do that pretty quickly. Fitting a heat pump in a home or any other building really, compared with a fossil gas boiler, in almost all cases really, but most cases, it will pretty immediately reduce the carbon emissions that are coming from your heating system. And this is because of things that have happened in the wider energy system. So the carbon emissions, the carbon intensity of the electricity grid has reduced an awful lot over the last few years, and it's hopefully going to carry on reducing further to the point at which there's next to nothing really involved in mains electricity in terms of carbon emissions. But the other thing, the other big impact that a heat pump has is that it's massively more efficient than a boiler. How much more efficient really does depend on your existing system. But as a rule of thumb, you're talking about at least 3 times better in terms of efficiency than a boiler. So you're using a lot less energy, and the energy that you are using is less carbon intensive. So if all you're bothered about is carbon emissions and nothing else, fitting a heat pump becomes a bit of a no-brainer. If you flick on to the next slide, Jonathan. Yeah, and this is just so that previous graph, that was from the Letty retrofit guide, which I'd really recommend everyone having a look at, just demonstrating the energy use intensity. This is a graph from the home retrofit planner that we use. And in each of the scenarios compared to the baseline there, a heat pump has been fitted and then some slightly different things have been done to the fabric. And basically fitting the heat pump makes a massive dent in those carbon emissions over time. Flick on. But I think that what we have to bear in mind is that for most people, in most circumstances, it's not just carbon emissions that are the concern. We live in a world in which there are lots of other variables that go into decision making. One of the big ones is affordability. And I know people talk a lot about, oh, well, if you fit a heat pump into a not very well insulated building, it will cost you a lot of money. It's like, well, yes, it probably will, but so would most fossil gas-based systems as well. Because we're now at the point where the efficiency of a heat pump kind of compensates, to some degree at least, for the cheapness of gas. But But if your aim, so that it means that having a heat pump system installed versus having a gas boiler system installed, they cost roughly the same to run. You can tweak the efficiency, or if you've got a particularly poor existing gas boiler, then a heat pump will make more of a difference. But roughly they're going to come out about the same in terms of cost based on current prices. If you want to make a dent in the affordability, that's when you have to start looking at doing something to the fabric, which, say in social housing, say in a lot of us in our own homes, we wouldn't necessarily just be thinking about swapping out and reducing carbon emissions. Some people want to save a bit of money as well, or at least want to hedge against future bill increases. Tackling the fabric helps you do that. If you flick on Jonathan, and that's exactly, I think, especially in social housing or where there's any risk of people being in fuel poverty, the way you tackle that is by improving the efficiency of the buildings so that you reduce demand, so that whatever their heating source is, whatever your heating source is, you're using less energy, therefore you're paying less for being warm, basically. That's a picture of a social housing decarbonisation scheme that we're involved in, where the space heating demand in those wimpy no fines flats has been reduced by about 70% from a silly number to something that's a bit more comfortable. If you flick on, I think the other thing to consider is comfort and health. A heat pump can definitely do something to improve comfort, partly to do with the way that the best types of systems are installed. So if it's been designed and installed properly as a full system, you should be getting a kind of constant low level of heat from it all the time. So the house isn't going through these like peaks and troughs of heating and discomfort, but it can't solve everything. And if you've got poor building fabric, so if you've got bad drafts or areas where you've got really cold surface temperatures in winter, either like single glazed windows or really badly insulated walls or walls with damp, those things need to be fixed before you're going to be comfortable and healthy. And the same kind of applies in summer as well, that though some heat pumps can be configured to do a bit of cooling, if you've got problems with overheating, you're probably going to need to think about insulation, but possibly also ventilation and shading to deal with that. Heat pump isn't necessarily going to solve those problems. And as the climate changes, it's likely that some of those things are going to become more significant as well. If you want to flick on again. Internal disruption. So some of the big barriers to us improving our housing stock aren't necessarily financial, although that's part of it. And they aren't necessarily technical, but they're things that are related to both of those and to do with things like disruption. If you're already living in a house, how much messing around do you want to do with it? A heat pump kind of needs to run at a relatively low flow temperature. So less than 45 degrees, less getting down to kind of 35 degrees is even better. To do that, you need to have appropriately sized emitters. So basically your radiators or underfloor heating if you have it, but that needs to be big enough to be able to put out enough heat to keep those rooms warm at that kind of temperature. The way that we've dealt with it in the past in a lot of not very well insulated houses is by running heating systems at a higher temperature. So the same size radiator will be putting more heat into that room. If you're looking at a house that maybe you can do a lot of the insulation work on the outside, for example, or you're just replacing some windows and you're doing some loft top-up and maybe a bit of wall insulation somewhere, if you do that insulation work, there's a greater chance that the existing radiators that you have can achieve comfort, can put enough heat into the building at that lower floor temperature, which therefore means that you are subject to a bit less disruption, which should also help reduce capital costs. But for a lot of people, if they've just decorated their house or something, that can be an important consideration. I wouldn't necessarily suggest that you'll get away with radiators like the one shown on the picture here, which is in Dom's house. And is kind of pretty skinny. But if you have like limited wall space as well, or limited room for fitting in radiators, then being able to balance that out by adding a decent level of insulation so that your radiators don't end up humongous, that can really make a difference to kind of how practical it is to fit a heat pump. If you knock on again. And then there's considerations of external disruption. So I think we're mostly talking about air source heat pumps here. And you do require some kind of external unit, and that has to go somewhere. And it does make a little bit of noise, though I think the noise thing is largely exaggerated and overblown. It's not that much noisier really than the average condensing boiler flue. But it does create noise, and there are regulations around this and regulations about how far away you can be from your neighbours. And in a lot of cases, in a lot of houses, there are probably limits to how much space you've actually got in your backyard or down the side of your house to be able to fit this kind of thing. It's great if you've got a kind of big suburban garden, but if you're looking in kind of slightly more urban built up areas, then it's a good idea to think about the size of that unit. I don't think anyone will need that's apparently the top picture there is the biggest heat pump in the country apparently, but it's for a district system, so that's a different way of dealing with space issues. But if you insulate your house, and it means that you can have a slightly reduced size of external unit, that can make it possible or even just more practical and more acceptable to you, your family members, your neighbours as well. And it should also reduce the capital costs of the system again as well, which can be, you know, an important barrier for a lot of people. If you flick on again, this one probably applies to fewer people really, but there are limits on the capacity of the connection between the house and the national grid. And if you've got a very large heat pump, sometimes that would end up requiring a 3-phase supply, and that might not be possible, and it definitely adds also a little bit of cost. So adding a kind of balanced, appropriate amount of insulation can also help eliminate the need for upgrading your grid connection. So that's another kind of benefit. All of these things are, I suppose the slightly annoying thing about it, I guess, is that this is going to be different in each house, and the same house with a similar grid connection but in a different place in the country might get a different answer to this question as well, because there are limits on grid capacity in certain local neighbourhoods as well. So it's just something to keep an eye on, but it's again, it's all about understanding your circumstances and your aims and what the balance is for you. If you flick on again. Yeah, this one again, if people are interested in it, and also I think it's something that we're probably going to have to do as part of the wider decarbonisation of the grid to some degree. But the better insulated your home, the less it matters when the heat for space heating goes into it, because it's doing that T-cozy job, it's retaining the heat for longer. So it means that you can have your heat pump installed and you can run it when either the electricity is cheapest or when the grid is less carbon intensive. Obviously, batteries do a similar kind of job as well. But if you're able to do this to some degree with your house, it's a sign of kind of how comfortable and easy to control it is, but it's also something that's kind of beneficial overall to the energy use in your home and comfort in your home. So with a really well insulated house, you can start to think of it like a big battery. So you can just kind of dump heat into it when it's when the signals are there from the supply side, not necessarily just it being about when the demand is there. If you flick on again. And yeah, so some people will, all of those things are kind of more at the house level, I guess, or the individual property level. I think as designers and as people kind of working in this area, we do also need to think about the whole system effects. So we're having to think about the entire energy system, not just individual homes. I think it's pretty much accepted that the more that we reduce demand the less we have to build new renewable energy, build new wind farms, all the rest of it. Or at least we might still build a lot of those, but we'll get to zero carbon a lot quicker in terms of decarbonising the electricity system. There's lots of arguments about exactly how far we need to go with that and what's optimal. I think in my work and in the way that we approach things, we kind of just try and do as much as we can within a given budget, within all the constraints on a project. Some of that is about heat pumps, which you can see that, again, that graph is from the LETI retrofit guide. Heat pumps are doing a lot of the work here because of that, because of their superior efficiency. But adding in fabric retrofit as well can make a significant dent on the amount of generation that's needed. So if we all kind of push that as far as we sensibly can, then that's helping the overall decarbonisation of the system. If you flick on again. So yeah, I guess, as I said, to be slightly annoying, how much insulation should fit in order to install a heat pump really depends on what it is you're trying to achieve, and how concerned you are about each of the above factors. That's going to vary depending on, say, if you're a social landlord and you're looking at your stock and you're thinking about your tenants and their ability to afford their bills, you probably want to do a fair amount of fabric work to protect them from fuel poverty. If you're in a house and you're kind of quite comfortable with how much you're paying at the moment, and you're quite comfortable physically as well, and your main concern is getting carbon out of the system as soon as possible, then maybe you don't do so much insulation work or even any at all, and you just fire away and get going with your heat pump. It's going to be different for different houses, for different budgets, for different circumstances. We've come to some conclusions, I think, about roughly where we should be heading, but every house and every client is different. So I think it's accommodating the budget and the different priorities that need to be met within that budget. But I'll tell you some rules of thumb that we've kind of come to anyway. So if you flick on again, Jonathan. I suppose the first thing I would say is that we try and focus on the metrics, the measures that tell us something about what we're interested in. And that means we generally are looking at space heating demand, usually normalized by floor area, but it might be total space heating demand, and peak load. So that's kind of on the coldest day, how much heat you need how much power you need to put into through the heat pump in order to achieve comfort. We don't use EPC ratings. They're kind of SAP rating because they're a measure of running cost really and not energy efficiency, and they also have some fairly questionable assumptions about kind of grid carbon intensity and assumptions about how heat pumps run that hopefully are going to change soon, but they're still, current EPCs aren't that great at telling you what's actually going on there. One thing I would say is that they do, if you've got your EPC certificate, you should be able to find a line on there somewhere that tells you what your space heating demand is in total for a year usually. If you divide that by your floor area, you'll start to get an idea of some of these things. The reason we look at space heating demand is because it tells you a bit about comfort and also about cost. So it's kind of how much energy you needing to buy to keep this place warm. And the reason we look at peak load is because it affects the size and the cost, both capital cost and running cost of your likely heat pump, and also whether kind of you're going to need to change the size of radiators. If you manage to kind of reduce your peak load and reduce your space heating demand by kind of 40–50%, then it's much, much less likely you'll have to change emitters, and you'll probably make a reasonable dent in what your energy bills are as well. If you flick on one. So these are kind of the rules of thumb that we work to, which there are always exceptions to. but for the majority of the houses we work with in most places with most clients, this is roughly where we're ending up. So it's a peak load of 10 kilowatts or less, or ideally in kind of more compact urban areas, more like 5 kilowatts. And space heating demand of less than 70 kilowatt hours per square meter per annum, I should have put on there, or ideally less than 50. But there are loads of constraints on those. Obviously, if you've got like a heritage building or you've got something that's in a listed or in a conservation area, there's only so much you can do. If you've got limits around space and access, there's only so much you can do. There's all kinds of caveats to this. The other thing to make sure of is that there aren't any major comfort or building health issues. There's no point really going to all the expense of putting in a heat pump when you've got gaping holes in all your windows and doors and that kind of thing. You might as well at least do the basics. It's interesting because especially in that space heating demand figure, and I think more conversations are happening about peak load now as well. A lot of people are coming to a kind of similar conclusion about where we're probably heading with retrofit, and it's around that 50 kilowatt hour space heating demand target roughly, but as I say, lots of caveats. Yeah, if you want to flick on one. So yeah, just to emphasize really what this means in every home is going to vary. If you've got a house that's already pretty well insulated and pretty comfortable, you don't mind your current running costs and you don't mind them maybe going up a bit in the future, given where things are at the moment, you could fit a heat pump now probably and save quite a lot of carbon. If your home's really cold and drafty, you've got a big, gaping barn door, or if you want to save more money on your bills and think about some of those other kind of system and demand issues, then at least some insulation is likely to be beneficial. And really, it's about as much as you can to get your demand down as low as possible. I think it's important in all of that to be really clear about what your aims and constraints are, whether you're a landlord or if it's your own home. Kind of thinking about what is it that you're actually trying to achieve, because how you then respond to each of these is going to vary depending on what your aims and priorities are.
Great. And that's the end of your presentation? That
is the end of my presentation, yes.
Fantastic. Very good time and everything. So it's given us a lot of food for thought there. And I'm glad there is some sort of rules of thumb, principles we can think about rather than just it's complicated. Be a relief to some people. Now, I would like to invite Leah. I don't know if you can whether you can unmute. And yeah, brilliant. And I don't know, Leah, 5 or 10 minutes, is that okay just to respond? I don't know.
Yeah. Can you hear me okay?
Yeah, go for it. Yeah, fantastic.
Cool. Yeah, so hi, my name is Leah Robson. I run an installation company, so we install ground and air source heat pumps, solar PV, solar thermal, EV chargers, renewables in general, really. Yeah, we're called Your Energy, Your Way. So yeah, Marianne's just done an excellent job of covering a huge amount of ground. It's brilliant. But just a few things to pick up on that might be useful just from an installer perspective. It's worth bearing in mind that if you're looking at budget constraints, the actual difference in cost between different sized heat pumps is very, very slight. It makes up a fraction of the cost of an installation. So obviously we all have an amount of money to spend on our property or the property that we're looking after, and that does tend to mean that if you were trying to do a straight calculation between, well, should I put some insulation on my house in order to reduce the size of the heat pump, the insulation is always going to be far, far more expensive than what you'll get in terms of a heat pump size reduction. So just obviously, as Marianne said, we're looking at cutting carbon primarily, but just worth noting that on a budget kind of level. I was just thinking about some of the constraints that we find in terms of people who'd love us to install heat pumps for them, and sometimes we have to say no. Actually, it's not a good idea. It's not the right thing for your home. I think we tend to find actually the trickiest home deal with would be a small detached solid wall house. Often we forget that by just being in a terrace, as long as you're not on the end, being in a mid terrace has an awful lot of impact on the amount of heat that your building loses. So if you're unfortunate enough to be in a small house, so we can't put really nice big radiators in each of your rooms, and you're detached, so you're not getting the benefit from any of your neighbors' warmth, that's definitely a scenario where you really are forced into a position to start with looking at some solid wall insulation. It's really hard to fit a heat pump in those kind of houses. One other thing that we come across as quite a tricky thing is people's love for those beautiful old cast iron radiators. Just please get rid of them. I know they're lovely and characterful, and I think we should give a design award to someone who could come up with a radiator that looks like that actually gives some heat out, because those are the kind of scenarios where we end up saying to people that heat pumps not going to work if you will insist on those radiators, because they just don't chuck out enough heat. On the radiator topic, I think there are a couple of phrases that we hear over and over again about heat pumps. One is ripping out the boiler, and the other is changing all my radiators. And they're kind of both said in fairly emotive ways. We never ever rip out a boiler. That would be incredibly dangerous. And also changing all the radiators in a house is rarely necessary. The great thing is that lots of plumbers just installed the radiator that fitted the size of the window, i.e. does it kind of stretch from sill to sill under the window. So lots of radiators in the past haven't really been installed according to the heat loss of the home. So it's kind of, it's generally when we do the heat loss calculation and work out how much heat your building's losing, it's a right old mix of which radiators need changing and which don't, and it's very, very rare for them to all be changed. But it's actually not as disruptive as you might think. Yes, you do have to have kind of plumbers going into the different rooms in your house, but tends to be concentrated in a particular area of the room. Lots of people, when they stop and look at their radiators, realize they actually pretty grim looking, could do with that coat of paint that's quite hard to apply. And very often, like the photo that Marianne showed, we're only talking about putting in a double thickness, double finned radiator, and often it can take up just the same amount of wall space. So I would I think we have something of a psychological barrier about this idea about swapping radiators, which I'd like us to try and get over, because it makes a massive amount of difference to the way that your home is heated, as it improves the feel of your house as well as the efficiency of your heat pump. Because if you can have a large enough radiator in a room where you can run the heat pump at, say, 35 degrees, what you're doing is creating quite a different sort of heat in the room. Radiators that run at 70 degrees basically run by convection heating, so they're setting up a little flow of air in your room in order to heat your room. Radiators that are running much cooler, kind of around 35, 40, are creating radiant heat out into the room. And I'm not a physicist, but from what I gather and what I've experienced personally in my own house, because we run our heating all last winter at 35 degrees, and we're just in a 1930s semi with cavity wall insulation, reasonable double glazing. What you find is that your kind of experience of temperature isn't just about the actual thermostat. Your experience of temperature is about the flows of air in the room. So, which is why the number one place to always start is getting rid of any drafts, because drafts not only bring massive amounts of cold air into a room, they also obviously are drafts. So they are moving air, which will make an 18-degree temperature room with moving air will feel colder to live in than an 18-degree temperature room without moving air. So yeah, if you can in any way get as big radiators as you can possibly stomach, that's a really good thing for a heat pump. And obviously insulation can help reduce the size of the radiators that you need, but the radiator sizes are really key. One other thing, this is perhaps a little bit controversial. The new boiler upgrade scheme that the government have brought out for heat pump subsidy actually says that you can't put in a hybrid heat pump, so a heat pump where a gas boiler is providing a backup in the particularly cold periods of the year. To my mind, I can kind of see why they've done it, but to my mind, it's a real shame, because I think actually a really nice approach, if you're looking at the long-term plan for your home, get a heat pump now. There's a subsidy; it won't be around forever. Then, if you can put, if you have to put in a hybrid, if you have to allow your gas boiler to stay, also, if your gas boiler is still pretty new and you don't want to waste it and throw it out, then put in a hybrid heat pump. And then when you insulate, you won't need the hybrid heat, you won't need the gas boiler anymore. So you can have the same size of heat pump, just no longer requiring the gas. So kind of allows a two-stage, but sadly subsidy not available for that. So if you're not worried about the subsidy, it's a pretty good approach. Jonathan, you've popped up. Does that mean I should be drawing to a close?
Yeah, I always say 5 to 10 minutes, but it was really fascinating. I love targeting the viscerality of ripping out things from the home. It's all very destructive. But if we hear from Matt now, and then we'll come back for Q&A. So, but it was really great to hear everything that you were saying. So it's fantastic. Okay, let's hand over to Matt then, who's going to be. So we've talked about heat pumps going in and performance, but there is also a technical challenge around understanding that performance and understanding the degree to which heat pumps are working. So Matt's been doing a lot of thinking and work on that, and that's what he's going to be talking about now.
Yeah, more sort of looking at graphs than thinking, but anyway, which is but here we go. So I will. Can people see that screen? Perfect.
Yes.
So, so I'd just like to begin this by saying that we know that heat pumps work. We know that that they work in a UK context. We know that there are fantastic installers out there. We know that like there were no doubts about that, and we also know that heat pumps and the success of heat pumps is absolutely essential for the decarbonisation of heat in the UK. So it's something that we need to make work. So that's just a caveat to say, because some of the things that I'll be talking about will be a sort of the more sort of negative side, and I think it's important to sort of caveat that first. So, so as Marianne has already said, from a carbon point of view, it may be a no-brainer, but from a cost point of view, it's more marginal still. So we know that it's important how a heat pump is performing, whether it's going to pay, whether it's going to be cost effective for the consumer. So in most cases in the UK, we're not metering for performance. In the cases where we are, there are reasons for some concerns, really. So, so a recent study looking at 2,200 installations found that more than a quarter had a seasonal performance factor of under 2.5, which is not good, really. Would cause you probably issues in terms of making that stack up against a gas boiler. But more worryingly, they found that there was no correlation at all between the installer performance forecast and the actual performance that was found. So, so there were concerns here, really. So, and the main concern is that it might hamper the rapid rollout of low carbon heating solutions, which we absolutely need. So, the second thing to say is just that. That this performance gap, which exists, is extremely varied. So there are some excellent examples, and there are some very poor examples. So we need to sort of do a bit of investigation to get to the bottom of why that is. So we've got some extremely enthusiastic members who graph absolutely every element of what's going on in their properties, and we found that they've come up with really high levels of performance. So it's looking at what we can learn from those users, and that can be applied to the more sort of for people who don't want to spend 3 or 4 hours a day thinking about their heating system. So I think it's worth saying that consumers are often discouraged from engaging with their heat pumps, which seems a shame when we know that it can really help in the optimization and usage of those. And when we did a recent survey of heat pump installers, we found that the vast majority said that yes, they did follow-up performance investigations and or monitoring. And what we found was that in most cases, that's a phone call a few weeks, a couple of months after installation, just to say, how's everything going? Which obviously, depending on the time of year, is not the same as sort of actual performance monitoring. So we did also speak to some installers who do very high level performance monitoring. So there's obviously sort of differences here. So this was all made much easier when we had the RHI, because there was something called the metering and monitoring service package, which was great. And it meant that people could install a very high level of metering in a way that would not only not cost them in the long term, but would actually pay itself back in a sort of shorter term and potentially be an income stream. So we're really hopeful that that data is going to be available to all to access in an anonymized format, so that we can do further analysis and really learn from this. So there are really great initiatives out there, like the Heat Pump Monitor project, which provides systems for a range of different sort of price ranges and complexities, and has really good user documentation to help people understand their heat pumps. But it is for a certain type of user, so they're very technical. They're not necessarily extremely easy to fit. They're quite the installation itself can be quite intrusive if you don't already have a heat meter, for example. So we're also looking at what data we can get from the actual heat pumps themselves, so from manufacturer APIs or from online dashboards. So we're keen to hear from other people who, particularly people who've got an MMSP package installed as well, so that we've got something to some sort of comparative data set to work with. So is there another way of working on this? Just removing this. Thanks, Jonathan. So in the UK, most of our sort of subsidies, our assessment processes are all based on modelling, and this isn't the case internationally. So looking at the case of California, they have developed a system called pay for performance. So essentially, you only receive subsidies for the installation of low carbon technologies, for example, when you demonstrate the amount of energy saved. So we're currently investigating a methodology called Caltrack, which is an open source methodology developed by the Linux Foundation Energy, and there's a really good report produced by the UK Green Finance Institute, which is really worth reading on this, and it basically lays out the need for metered energy assessment and savings in the UK, because we need to be able to verify these things in order to be able to give people the confidence really to invest significant amounts of money in these technologies. And it also opens up a whole world of additional things like heaters as a service, for example. So just going on to say let me try with move my little black box again. So so how does that work? So you've got so it really, it's making use of the smart meter data that we've now got. So there's always been a lot of sort of guesswork and assumptions really within things like SAP, because there has to be, because fortunately we're not monitoring our citizens and their daily activities. So, but we are now monitoring energy usage, and we're doing that in a very at a very high resolution really. So so by taking that half-hourly data and combining it with local weather data, you can build up a picture of energy demand over the course of the year for every half an hour. So it means that you can normalize that energy data, not just for weather, but also for occupancy, which when we're trying to do comparative studies over something like lockdown is a very important factor. So and the interesting thing is how this can be used to feed into to our assessment tools for modeling heat pumps. So it's not going to replace it by any stretch of the imagination, but for a bit of sense checking, I think it's very useful to be able to combine it post installation with heat pump data and a range of other metrics like energy usage and flow and return and internal temperature. It means that we can help to really find the best way of using our heat pumps and to optimize them, and to identify and highlight and fix any problems at an early stage after installation. So yeah, that's something that we are sort of working on at the moment, and we're keen to have others, particularly who have heat pumps, who have experience in heat pump installation, to sort of help to feed into that process. So hopefully that wasn't too technical, and that's all from me. Just mute yourself.
Great. Thanks very much, Matt. That was fantastic and really, really fascinating. And yeah, as Matt says, we're going to be looking at this in greater detail over the next few months. And if people are interested in getting involved, get in touch really to Carbon Co-op. Brilliant. Now, Sandy, you've been monitoring the Q&A. We've got 21 questions. We've got 10 minutes to get through. So that's like 15 seconds per question. But maybe we'll just go for a few. So if Leah and Marianne could join us, and Matt as well. I'll make sure to mute myself appropriately.
Yeah, great. Yeah, some really interesting questions in the chat. Thanks everyone for sharing. I wanted to just read out a couple. So Lewis asks, we tend to fit air to water heat pumps in the UK which don't do cooling. Is this a mistake with heat waves increasing? Should we be looking at more air to air heat pumps? And I'm just going to ask a couple questions and then get your thoughts. And then Darren asks about the improved efficiency of a heat pump outweighing the cost benefit of gas, and if that efficiency is dependent on proper emitters. So for example, if you stick a heat pump through the existing radiators, will the efficiency benefits of the heat pump be negated? And a similar kind of question on efficiency is about the pipe diameter size from the heat pump to the radiators. Is there a preferred size, or is it dependent on the length and number of bends in the runs? And is copper better than poly? So a couple of questions there.
Right. Yeah, and don't feel everyone needs to weigh in on all the questions, but I can already assume some people will. Who'd like to go first? Leah?
Yeah, I'll go. Shall I? They seem a bit installery, some of them. I'll try and be quick. Air to air, great if you're putting it in a new build. Just not something we have the infrastructure for generally in our homes in this country. It's a nice option if you're building, which everyone in the southeast seems to be doing at the moment, a big downstairs extension with a kind of big open plan area. You could just have one air to air unit going, or up in a loft can be a good can be a good option. But yeah, in general, getting air ducting through a whole house, quite tricky. Yes, about the efficiency, if a heat pump's efficiency is related to the outdoor temperature, this is air source, but the outdoor temperature that it's running at and how hot you're asking the water to be that it's producing. So the bigger the radiators, the cooler the water can be, the more efficient the heat pump. Pipe sizing, the bigger the pipes, the more water they can carry quickly without being noisy, the more heat they can carry. So yes, you can have small diameter pipes if your home is well insulated. Plastic has a smaller diameter inside than copper. So, so small plastic pipes are tricky, and you need a good installer to work all that out and size your pipes properly.
Great. Anyone else want to weigh in on any of those? No, that's
I think Leah
fine.
covered it.
Let's keep going through the questions.
Great. So Shazia had a question about insulating older properties and allowing it to breathe sufficiently to avoid future damp problems, yet making it suitable for a heat pump. And then there was also a question about ventilation. This was in the chat, so it's not in the Q&A, but there was a question about all the air tightness work that Leah was mentioning, and whether ventilation just by opening windows would be sufficient, or if there's other options there for having done air tightness work.
Cool. There's a couple
I
for
can
Marianne to
probably
weigh in on.
do those ones. So breathability, when we say breathability, we're not talking about air, we're talking about moisture movement usually. So that's a whole other topic area that I don't plan to answer now, but there are other resources out there. And especially if you're looking at older properties, there's Cumbria Action for Sustainability, done some sessions with them on that, and STBA, Sustainable Traditional Buildings Alliance, have a lot of good resources. On the ventilation, planned ventilation systems are always better because they're more reliable and you know they're going to work, and you're not going to end up with problems with indoor air quality or moisture building up. So having some kind of ventilation system that probably relies on a mechanical system of some kind, preferably running continuously and not just relying on people opening windows. Because apart from anything else, in the middle of winter, that's unpleasant and people don't end up doing it.
Great. Okay, some more questions. I don't know if there's any data and monitoring questions in there, or they perhaps perhaps not.
I think, sorry, there's a question because I think it relates to a blog that someone's posted in the Q&A as well. And forgive me, I should know the name of this person because I'm sure I follow them on Twitter, but just questioning the climate change committee's scenarios around the kind of balanced pathway to decarbonize the energy system versus what we're saying about the kind of 50 to 70 kilowatt hour space heating demand targets. And we're kind of pushing a bit further than I think is assumed by some of the like high level emissions reductions strategies. And you know, they've pointed out basically there's a bit of a dichotomy between that high level system stuff and what is the most economically efficient way of achieving those carbon emissions reductions versus what we're saying about what we're trying to achieve in individual homes, and how you deal with that tension. And my honest answer is I don't know if you can deal with that tension, because that 50 to 70 kilowatt hour target is about it's about comfort, but in a lot of cases it's also about affordability and running costs, and especially in social housing, making sure that people don't end up in fuel poverty. And you could just do like small reductions, but then you've still got a bunch of people who are in fuel poverty the way that things are currently structured and likely to be structured for a while, given benefits and all the rest of it. So I think it's really important that there might be a kind of a disagreement between the two, but what really interests me is kind of making an impact on people's everyday lives and making them better. So that's where that kind of 50 to 70 kilowatt hour target comes from.
Yeah, there's lots of trade-offs there, aren't there? In that policy making space. So yeah, Sandy, any more questions?
Yeah, I think two kind of areas, one around noise. So Tina has a question about a typical social housing terrace where there's 6 meters between party walls and poor soundproofing. If the heat pump is placed centrally, so 3 meters from each party wall, would a small 5 kilowatt heat pump be audible from the adjacent gardens? And then another noise question is about whether the noise from an air source heat pump is about the same as an external compressor for an air conditioning system.
Don't know, Leah, if you want to weigh in on that.
Yeah, sorry, I didn't quite follow the scenario with the gardens, but the thing to remember with hearing other people's heat pumps when you're in the garden is that it's running an awful lot less in the summer when you're likely to be out in the garden. It's like really only going to be doing your hot water at that point. And we tend to say to customers who are concerned about the noise, just go and listen to somebody else's heat pump. It's like wind turbines. It's so subjective. One person's unacceptable level of noise is another person's don't really hear it. So yeah, I would just counsel go and find one. And yeah, it will be very similar to a similar size of air conditioning unit. We call it an air conditioner. Actually, generally it's a heat pump in physics and scientific terms.
Right. I think we've got room just for a couple more questions then, Sandy.
Yep, that's great. So there was a question about training up community energy groups to do initial heat pump surveys. Would that give customers a good idea of what kind of insulation or radiator upgrades they'd need, or would it cause more complications? And then I'll ask one final question. I think this one might be good. So Paul has shared that CIBSE did a recent whole life cycle analysis, which showed that heat pumps and gas boilers are very similar in terms of emissions, but in the future, they say as lower CO2 refrigerants like propane come in, that will change in favor of heat pumps. Does that ring any bells?
Cool. So maybe Matt could weigh in on the community energy groups and heat pump surveys.
Maybe I could, yeah. So so I think that sort of feeds into some of the work that we're already doing as part of the home retrofit planner, or as what PPR are now doing. But I mean, I think there are a number of tools available which might help people to identify whether something is a suitable candidate. I mean, I think really any assessment needs to be done by an installer, ideally, or a sort of qualified designer. There's a lot of useful stuff, I think, which we've done recently as part of the Heat Pump Challenge, where we asked 50 people over the winter to turn their heating systems down to 50 degrees, the flow temperature of their boilers. And that's been really useful in terms of people getting an idea of areas where low flow temperature heating is not going to be suitable, areas where they are going to need to potentially increase insulation, or they are going to need to enlarge radiator sizes and that kind of thing. So yeah, I think encouraging people to sort of take a chance with the stuff that they've got already, and see how that works. I think I would probably not suggest community groups doing heat pump assessments at this stage. I'm not sure whether others would concur with that.
Yeah, and I also wanted to flag that as part of this work that we're doing with MCS and Electricity Northwest, we'll be doing at least one session specifically for community energy groups, because we know there's a lot of interest in this area. And as kind of Matt said, we want to help people manage and engage in that process in a way that's appropriate. So yeah. Any last comments then? There was the propane refrigerants thing before we finish off the session, or any comments at all that people just want to leave us with?
I suppose I'd just echo Matt's point on the surveys, that like to get a good survey done to inform like heat pump design and system design, so it's not just about the heat pump, it's about the whole system, that requires some skill and some knowledge. And it's not that community energy groups wouldn't necessarily be capable of that, but I don't think it's the kind of thing you ask a bunch of volunteers to do after a couple of hours training. That's not appropriate.
Yeah. Great. Leah, any last words from you as we wrap up now?
I might slightly disagree on the surveys. I think that it was very clear what they were trying to achieve. It was very clear that they weren't an actual, like, you are about to have a heat pump installed survey. If they were getting a rough idea using some rules of thumb, they could have some value.
Cool.
But be careful of what you're trying to do with them.
And yeah, cool. And maybe we can come back to that then in this other session. Right. I really want to thank Matt, Leah, and Marianne. And I want to flag up what's coming next. So basically, as I discussed, we're continuing this project and we have more learning to share, which is around some of the services and how things might work in the future around heat pump installations and matching heat pumps and fabric upgrades and that sort of thing. This is just a bit of a kind of like preview for that. So yeah, thank you for coming. We'll circulate things via the attendee list. We also have just one little request, and that is we're looking for your feedback. Sandy, do you want to talk us through the feedback form?
Yeah, absolutely. So this form has just a couple of different ways that you can provide feedback. I've popped the link in the chat. So if you just click on that link in the chat, then you can use the pen tool, which is on the left-hand side, to mark on the horizontal line from 1 to 10 how you would rate the session. And then we have a few different sticky notes you can add with things to improve on the left, things that were good on the right, and any recommendations or ideas you have can go in the middle. So yeah, I'll keep an eye on that and hopefully it's easy enough to use. But yeah, if you could fill that in now or after the session, that would be really helpful for us. And yes, we will be sending out a recording and slides afterwards. We had quite a few questions about that. We will be sending those out to you, I believe, just on the email that people signed up with. Is that how we'll be sending those out?
Yeah, that'll be going out that way. So yeah,
that's great.
We'll leave this up for a while, but we'll pause recording now. Thank you everyone for coming, and thanks to all the presenters as well.